Welcome back to the channel, everybody. Another 1113 installment here today, and I tried doing this video about a week ago and it didn't work out. I'll explain why, hopefully quickly. So I ended up scrapping all that prior footage and we're starting over. So like I said, I've got about a week involved into everything up to this point right here, which doesn't look like much, but so pre-combustion chamber time. I have the four laid out here that offend me the least of the roughly 3 sets of them that I have. I ordered all the seals for them. The copper seal goes at the base down here. That is a 4B5647 part number. That is also the same number that's in the old manual, so that has not changed. And if you look at the serial number range for 1113, it lists a 1A2298 rubber seal that goes up here on the 2A5745 chamber. So I also got a set of the 1A2298 O-ring seals, brand new. So I go to put these in the other day, and the copper seal at the base is correct, but the 1A2298 is way too big around to fit into that groove right there. It didn't take me long at all to realize that was just never going to fit. This thing's about 3 times as big around, diametrically speaking, as what would ever fit in that groove. So I had to do some research, and it turns out from 5J1 all the way up through 5J4353, they used an older style chamber that took that 1A2298 seal. But effective with 5J4354, they changed to the 8B4440 chamber, which is what I have here, that takes a 7B6868 seal that is much smaller around than what the earlier 1A2298s were. And I did not do my due diligence to make sure I had like the late style chambers like I have here or the early style ones. Turns out everything I have here, from engines ranging from first model year of D3400 to last model year, and then another couple in between, are all of the newer pre-combustion chamber designs. So they all have the smaller groove, and to be honest with you, this is the first time I've really ripped out all the Precoms from a D3400. I've always just kind of used the live and let live strategy up to this point, but going by the parts manual breakdowns, you really don't see much of a difference in that illustration, and I never knew that we had 2 different style chambers. I even learned something new right here. So that pretty much put me out of action until I found the correct style of upper O-ring seals. So in order to get something done, we're kind of in the fuel injector range right here. I've got several sets of fuel injectors for 1113 that I could potentially use. And we had been doing some playing around with a couple of pressure testers for injectors that Senior has fixed up. So I kind of just, while I was waiting for parts, rolled right on into that. So here's the footage from back then. All right, so it's time to start lining up a set of fuel injectors to use in 1113. These are the ones that came out of that tractor. We have them numbered 1, 2, 3, and 4. I'm just going to test these things on here. We're going to see where they crack. These 3 3/4 bore injectors, you want to see them crack around 1500 psi. Check spray pattern, make sure they're not leaking, dripping, what have you. And I don't know what condition these are in. I don't know how long 1113 sat, and of course nobody's ever heard 1113 run. So we're going to test these, see where they are. And out of curiosity, I have this other set of D2 injectors. This is what I had in old 2115. I bought these for new old stock. You can see this one's got a lot of OD green on it. The other one's got some yellow. That one's got some green. These should only have about 20 hours of operation on them. I'm going to put these things through the tester too, so we can get a good baseline between the unknowns of 1113 versus a set that I have run before.
Okay, got fuel in the system. We're screened. Got a .0015 screened in there, so we're pretty fine on that. And first thing we got to do is prime this system up, make sure to get a good flow going out of there. We got a primer,
or a little bleeder screw
right here. We'll just go until we get some fuel leaking out of there.
I saw just a little bit starting to come out.
Okay, a little bit of fuel coming. I can see her weeping out, so we'll close the bleeder screw off. And we'll see what our flow is. We'll make sure our line is flushed.
Looking pretty good coming out of there.
Okay, I like that. So ready to hook an injector up.
All right, we got injector number 1 out of 1113 hooked to the line. We're just going to check spray pattern first. We're not going to worry about this gauge. He's just going to pump that up, and we're going to see what happens out here. You can see it cones a little bit.
That's looking good to me.
It's not looking too bad. So next function, he is going to open that valve on the side, and that is going to connect us up to the pressure gauge. All right, needle's starting to move. Look at that. 1500, just about right on. It cracks. All right, we just put injector number 2 on the tester. That's not really as nice of a spray.
We got a little dripping going on. I can see a drip off the side.
Yep.
Too.
Let's see about pressure on that one. Ooh, it's not cracking until 2500 psi.
About 2500.
Pump on that some more. Go a little faster.
A solid stream.
Yeah, it doesn't even really spray. It's just kind of, it's a stream that comes out. That's not good. That's not a very good injector right there. All right, moving on to injector number 3. That spray pattern is not bad.
Hard good to me.
Hard to see it in the sun, but
yeah.
Let's see
it out and see what it looks like.
Well, let's just see where it cracks.
Okay.
Okay, we're 1600 psi, I'd say.
1550 to 1600.
Still, though, I'm not horribly disappointed with that spray pattern.
No, that one looks good.
All right, number 4. Spray is okay.
I see a lot of dripping though.
Yeah, I've seen better. Let's see
Kind of
what
sprays off to the side.
Yeah. Let's see where it cracks. Ooh, that's not good. So that thing is dribbling all the time. Anytime there's pressure on it, look at that, it's leaking.
Steady dribble.
That injector is bad. So basically we're about 2 for 2 on the 1113 originals, which is not great, but it's kind of nice having a toy like this so you can play around with these a little bit and get a little bit of an idea of what you got before you just have to put them on a running engine and see what happens. So I'm going to test the 4 new old stock ones that I used to have in 2115 now. Got the OD green one on here. We'll just see what it does. It's got a good squeak to it too. Great pattern. It's a nice mist coming out of that thing. I think that's the best one I've seen yet. We're like 1450 we're cracking on that one. Cracks a little on the light side, but man, I can't argue about that spray pattern at all.
Pressure good.
Holding pressure too. Oh yeah. All in all, I'd say we got a pretty good injector right there. We're gonna go and test those other 3. I'll report back.
I think it looks good.
Excellent. I like that. Another fine spray out of that one. Boy, I'm liking these new old stock units. Right on 1500 too.
About 1500.
All right, so back to present day. We did quite a bit of testing of injectors that day. We even did the old set that I had taken out of 2115 that I'd replaced with the new old stock ones, just to get a pretty good idea what all we had. And well, of the 1113 originals, 2 for 4 were actually good at all, number 1 and number 3. But based on the results and the cracking pressures for the new old stock ones, they all had excellent spray. I'm going with the new old stock units that I had got for 2115. Like I say, these should only have about 20 operating hours on them. I cut new cork rings to go underneath the retention nuts. Those are just kind of to prevent moisture, dust, whatever from migrating down into the threads. So that's a set of injectors I'm going to use. I'm going to hold 1 and 3 in reserve from 1113 to possibly swap out if one of these doesn't seem like it wants to jive. But of the old worn out 2115 originals, honestly, the cracking pressures are a bit low, 12 to 1300. They did not have horrible spray. Those could probably be used in a pinch in another machine, but we've got the fuel injectors sorted for now for what we're going to use in 1113. Now, the only downside of this process is I don't have any tools or equipment to work on those injectors myself, and I don't know where to get any. I have not been able to find any. I've been on the lookout, but no other diesel or injector places that I know of in my area have anything for working on old injectors like that either. So there used to be a guy up until about a year or so ago that was affiliated with the Antique Caterpillar Machinery Owners Club. They had all the test equipment to rehab those things, to lap seats. I mean, anything that you'd need to do, he could do it. Unfortunately, he has since retired from that, and nobody has taken his position. So in the meantime, I'll keep all those old injectors, or all those bad ones, I should say, and maybe someday I might find some tools and find some knowledge on how to work on those myself, or maybe someday somebody will come along that is able to repair some of those. Either way, at this point, it's just a waiting game, and you just go with the good ones that you've got. But on a more positive note, I have now finally received the CAT 7B6868 upper O-ring seals for these pre-combustion chambers for the style that I have. And from the research that I've done, it sounds like the majority of chambers you're likely to run into are going to be this later design. I'm sure there's still a few of the older original ones that must have had a much wider and deeper O-ring groove left floating around out there, but it sounds like the vast majority were switched over to these newer style decades and decades ago. So, and even comparing the two styles of O-ring, you can see this newer one is a much lower profile. It's going to be a much better fit on these chambers. So I think we're finally ready to try putting these in. All right, so yes, indeed, those O-rings do fit those pre-combustion chambers much, much better. I've got this one coated in some of that tire mounting lubricant, the same stuff that I used on the O-ring seals for the cylinder liners. If you don't remember all that, link should be popping up right here. You can go back and relive that whole segment. And as I said earlier, I'm going to use the copper coat on the copper gasket that goes at the base right here. What I'll do is coat up the gasket. I'll coat up the seat here. I'll also coat up the seat inside the cylinder head, and I'll drop that gasket in because there's a nice little retention area for that to sit down there. I'll also get some rubber lubricant on these bores right here, and after that you just put the chamber in and thread it down. Alright, so I'm just going to turn them in until they contact the base with this ratchet right there. Now I'll put the torque wrench on it, and this is another one of the rare items where the D3400 manual lists a torque spec. This is 150 pound-feet. There we go. Number one done. Number two. Number three. There's number four. Man, I hope those seal. Now to finish up with these pre-combustion chambers, each one has this little Allen head screw that goes in and is like a kind of like a little jam bolt. It's just a little retention screw. And because these thread into the water jacket, each one has a little copper sealing washer that has to go beneath the head. I don't even know the part number for these. I just pull them out of my kit. It's a 1/4 inch ID copper washer, so nothing special there. Okay, next up, the injectors and lines. I'll just set the injectors in place for now. We're not going to tighten anything. And again, just take care to keep everything absolutely clean with the fuel system. You don't want to let dirt and debris get into these fuel lines. And what I'll do before I tighten the injectors down is just kind of loosely start each end here, because final position of the injector is kind of going to be dictated by the amount of tension the line exerts upon it. So with everything just hand started, we'll run the nut down. We'll just tighten the lines now. And the injector. This is where making this special injector socket really comes in handy. So after performing the same sequence on the other 3 injectors, everything here is fully installed. Now, for the more experienced diesel mechanics out there, you'll already know this. For anyone that is not, the reason why we have varying numbers of coils in these injector lines is because in a diesel engine like this, you will get your most accurate fuel volume, fuel delivery to the injectors if each line is the same length. So that's why number 2 has to span just a little short distance. That's why it has a lot of coils. Number 4 has to span a long distance. It doesn't have many coils at all. But from point A to point B on each one of these lines, each one is the same length. So that's the reason for the difference there. Next up, we have the fuel return line that goes atop the injectors. Now we have 2 different styles right here. This one back here is the early version that is correct for 1113. This is the later version, and you can see this line would arc down to the rear of the injectors. This newer line will arc down to the front of them. The only other difference is, well, the main difference I should say, the early style line is a brazed copper and brass affair. We have these little T-junction fittings on there. The banjo bolt ends are all soldered on. And of course, it's non-ferrous. Whereas this later style is a welded steel. You can see, you can pick it up with a magnet. Installation of the line is pretty simple. First, we have a copper seal that goes on top of each injector. And then the line just goes up on top. And we'll start these bolts down through. Being careful not to knock off any of the other copper seals. All right, so with those bolts tight, we are ready to install the final leg of the diesel fuel return system, and it is this. In classic Caterpillar fashion, we just dead-ended out at the end of a tube, let it run all over. But here was 1113's original line. It fits in here, goes up on the fitting there, fits down in behind the pinion clutch down in here, and you can see we have a very damaged portion right there. I think somebody was doing some significant prying in that area at one time, trying to do some pinion clutch drive work. So what I ended up doing, I'm going to set this here by this other one. That's pretty much impossible to get a mashed over kink like that out of a line, so we kind of had to discard it. But this one's off of old 5J2115. Actually, it wasn't in too bad a shape. I did clean it up a little bit, have a good look at it. It still has some of the battle scars in it from before. But for the most part, it was still retaining its former shape. I took a few little minor crooks and bends out of there, but we're going to use this one instead. A little bit of a hold-down bracket on the bottom. Now, a true test of skill. See if I can install this with one hand, record and talk at the same time, huh? So, started in the top fitting, enough to hold it into position. Now at the bottom down here, the hold down goes underneath this side cover bolt. So, yeah, one-handed, folks. Gotta get it. Come on. Oh, all right, we gotta start this over again. There we go. Oh, it fell down. Now the washer came off the bolt. This is live, folks. You're seeing it live. There we go. We got that all started. Just run that one down hand tight for now as well. There. Everything's tightened in. So that part's done. And this is the right, correct, and proper line, and this is exactly how Cat did it. They just bring it down here and just let it drip. The only reason it actually angles back this far is to hopefully keep it off of that mainspring that goes right there and get it safely down behind. And if you guys will forgive me, I have also installed another return line off camera. This one that comes from the upper port here on the fuel filter tower, and it goes down between the tower and the engine block to the bottom down here. I made reference to this a few times. You can see we're spliced off. Go over to, that's the return fitting from the little trays, the little catch trays that are below each one of these injection pumps. That feeds that and will run out. The telltale drain that comes from up here at the bottom of the fuel transfer pump when those packing seals start to leak, that also tees into here. And from the filter tower vent up here as well, bleeder vent, they all come down and exit at the front right here. And that also just drips out and onto the ground. And back in the day, that's how Caterpillar did it. Now, I was going to pre-fit this one off camera, take it out, and then put it back in once everything was right. And I'm sorry, folks, but for as much fun as it was to get all of those fittings lined in, once I got that thing home, I made the decision that it was staying there. So you'll just have to use your imagination. But if you don't believe me that that is actually how all this stuff is plumbed, just take a look at various archive photos when these were brand new at the factory. They already had like catch pans, drip trays underneath each one. I just love all the external plumbing on these things. Just the bolts and the fittings and the soldered connections and the everything going everywhere. Steampunk. That's that's about the best way I can describe these early engines like this. I really like these things, but okay, it's nice to have this fuel system done. Pre-combustion chambers finally in, injectors in, associated lines in, done. So that's pretty much going to wrap the video for today, everybody. As always, thanks for watching. I always appreciate the views. Leave comments down below if you are so inclined. And as always, I hope to see you back again.